Hello everyone, my name is Ping with Optigo Networks. Thank you very much for watching this video. We had a wonderful webinar today with Steve Card on troubleshooting BACnet in Wireshark. Instead of broadcasting the entire 1-hour webinar, we are creating a small highlight version, 10-15 minute version of a video capturing everything that we did and a few of the major questions that were asked. So enjoy for everyone that joined the webinar. Thank you very much. Anyone who missed it, enjoy this video and don't hesitate to reach out for any questions. A quick note about Optigo Networks. We're a company based in Vancouver, Canada, and we develop specialized networking products for the smart building industry. One of the products we developed is Visual BACnet, which is very relevant to troubleshooting BACnet using packet captures. We had the luxury and the honor to have Steve Card join us on this webinar. Steve Card is a long-term volunteer and contributor to BACnet International, currently working on LostStopper, and one of the original author of the BACnet dissecting stack for Wireshark. So it was really wonderful to have Steve, and thank you again to Steve for his great help. We are going to look at how to capture BACnet packets, isolating BACnet traffic, and so on. And I'll cover a few of the questions that were asked at the webinar. Let's jump right into it. To capture Wireshark, one of the questions we asked to Steve is, where should we run Wireshark? The recommendation is to run it on the VMS, the workstation, on a controller, or through a hub if you have access to that. Or even, and if you don't, if you do have an IT person capable of helping you, use the monitoring port or spanning port, or sometimes also called a mirror port on a managed switch, which allows to capture every packet going through that switch. This will give you a full visibility of all the traffic that's happening. Steve also recommended to know if you have an idea where the problem may arise, run the capture on that device or the controller if you're capable of doing it, or put a hub in between if it's an MSTP link. There are ways, there are tools out there that allows to tap into the MSTP wires and connect right into it and capture the MSTP frames. Wireshark does allow that, especially in version 2.0 and above. Right, so when we're in Wireshark, this is already running, but if you were to capture the frames, you just go to Start, select the interface you want. But a quick trick, if you want to capture just Wireshark, BACnet frames, you can put in a filter that specifies a port range or the port that BACnet uses. So traditionally, or most of the time, BACnet will use port 47808. And by standard, it allows it to go all the way to 47823. If you want to capture it all, you can use this little filter here, UTP port range 47808-47823. In some cases, you'll use non-standard BACnet ports, and this is where you can adjust it to capture those packets. All right, so once it's captured with Wireshark and you create a PCAP file, a packet capture file, open it, and this is where you'll do all this filtering and manipulation to help you understand where the problems are. In this case, this Wireshark, this PCAP file was provided to Steve a long time ago from a user that claimed he sees some anomalies on the network. He thinks maybe there's some flooding, there's some delays, some problems there. And for everyone's understanding, we scrubbed this file to remove any sensitive information. This is anonymized, so the IP addresses and the MAC addresses are not actually from the original file. So Steve recommended the first thing to do is to take a look at how many BACnet frames you may have. So one of the ways to do it is to use the filter BACnet. This will capture every BACnet, every frame with a BACnet section. Back app, in case there's no BACnet section, but only a BACnet application stack to the frame. And Steve also recommended to look at BC LC for the IP layer encapsulation. So once you've typed in all three of them with the double vertical bars, or what we call pipe, hit enter. This will filter only, now leaving you only the BACnet frames. If you look at the bottom of your screen, you'll see there's about 9,700 BACnet packets. So again, the user came to Steve and suspected there may be some flooding here. So let's take a look at how many of these frames are broadcast frames. So an easy way to do that is to add, you can add a bracket around this, and add only broadcast frames. So a broadcast frame will always have an address in Ethernet of 6F bytes. Once you have that, I'm missing a double equal. This will give you all the broadcast BACnet frames. So you see a large majority of them are broadcast BACnet frames at 9,600 compared to 9,700. One little trick in Wireshark, you can pull down, go to statistics, pull down the conversation, and this will show you, you can select either you want to look at Ethernet layer or IP layer. One important thing is to click this limit display filter. It will take into account the filter that you just used in Wireshark, and then you can sort. And this will give you a very quick look at what are the most chatty pairs. You can see here, because we filtered only broadcast frames, address B will always end with .255, which means broadcast. And just as an evidence, you go to Ethernet again. You see the second address, or the destination address, will always be a broadcast Ethernet frame. So again, this just gives you an idea, which device is chattiest. So in this particular one, this 2233, and so on, is your chattiest device. If you go to IPv4, this can give you the IP version of it, 192.168.242.118. All right, let's move on. Let's think that one of the most impactful frame in BACnet is your whois. Whois are essential to BACnet systems, but they are broadcast. They go everywhere and can create an incredible amount of flooded traffic and can really inundate your networking system, causing delays, performance issues, and so on. So let's look at only whois frames. So Steve and a team many years ago created an amazing stack for Wireshark that is now what we're using. So if you want to just look at whois frames, whois is an unconfirmed service. So you can type it in, or show you another way to do it. You can go here to expressions and build it out using a GUI, a lot easier to do. So BACnet application, pull it down. It'll show you every available object that you can use as filter. So in this case, we're going to look for unconfirmed service and choose your whois, which, by the way, you can see it's value 8. If you go to the BACnet standard, you can see that unconfirmed service 8 is mapped to whois. Hit enter. And hit enter again to apply the filter. And now you have only the whois frames. Again, let's take a look at it. 6,100 out of 9,700 frames are whois broadcast, always broadcast frames in this case. Quick trick, if you expect to use this filter a lot, a quick way to do it is to add it to a shortcut. So you put the little plus button right next to it, give it a name, and verify the filter you want, hit enter, and now you have it for future use. Right. Let's say we took a look, let's say we can now again use another built-in Wireshark function, go to endpoints. Just another way to take a look at it. These are endpoints of both start or destinations. sort by number of packets. So you can see that the chattiest device is sending out, oh, I apologize, you got to add the filter. The chattiest device, or the device sending out the most who is this device 192.168.242.9. Let's take a look at that. If you wanted to just filter out that one, you can add to this expression. So, and double and percent means to add to the expression a frame that matches both filter expressions. And in this case, we're going to do IP address 192.168.242.9. Oops, again, double equal, I apologize. And enter. And now you have all the frames sent out by 192.168.242 that are who is frames. If you want to here, you can expand a frame, take a look at what type of frame it's asking for, and so on. All right. We talked about how who is frames are important and essential, but there's also a special type of who is frames that are called who is global who is frames. And Steve explained that global who is frames are very common to discover what is connected to the BACnet system. But they can have a very negative effect if used a lot on the system. Global who is will cause every device to respond with an IM, which creates an incredible amount of traffic and again can create performance issues, delays, unwanted behaviors. So if we wanted to look for just who is global who is frames, here's a little trick. Now, global who is frames will typically show up in two different types. Again, thank you to one of the attendees for pointing it out. One type would be frames that have no limit set to it. And again, thank you to Stephen and the team that created Stack. This is actually very easy to do. You can do backapp dot who is, and you see right here, there's two different features, expressions you can use. So in this case, it doesn't matter which one you use. We want a frame that is who is, that's the first portion of it, but has no high limit. So you just put an exclamation mark in front of the expression, it means no, not, inverse. Again, if you apply this one, and you see there's 4 frames here with a upper limit that doesn't exist, which means these are global who is's. Again, thank you to Jeff pointing out another type of who is, global who is frames are frames where the lower limit is set to 0 and the upper limit is set to 4.1 million. I won't show in this example, but you could modify this expression to look for those type of frames also. All right, let's continue. A very popular way of exchanging messages in BACnet is sending requests and followed by acknowledgements. And one very difficult thing to diagnose is delays between devices. If a request goes out and acknowledgement has a significant delay, it can have a very bad behavior to your BACnet system. So in Wireshark, if you wanted to look for these communications, these what we call confirm services, you can again use expression builder. So let's do that this time. And do expression builder. BACnet. Oh. Backapp. That are oh no, not this one. Use backapp. Confirm services. And we're not looking for one in particular. We're just going to look for all of them right now. And again, apply this to enter to the bar. And then apply it again. Make sure it takes. And this will show you all the confirmed services, both the requests and the acknowledgements. Oh, what happened here? Oh, pardon me. So just like that, without the 0. And here we go. A little trick here. If you wanted to, and I'll show you why, you want to add the invoke ID, which is an essential part to BACnet frames. You can click on the field, invoke ID, right-click on it, and apply as a column. And just for fun here, we're going to add one more. We're going to add the device ID. Actually, to be more exact, this is the instance ID, instance number. Add it here. So now we expanded the single line view to include the invoke ID and the instance number. The reason why I did that is just show you a little quick trick. If you wanted to, sometimes you want to export these files to, say, Excel and do further manipulation, do things like sorting and unification or run some rules. So you can export to a CSV file, just the display package, and make sure that you, oh yeah, that's right, and then just export to a file. And now you can go to Excel, for example, or any other spreadsheet program, and you can manipulate these. You can run if statements, you can sort them, whatever you want. Again, very, very powerful when you're trying to diagnose some very complex issues. One quick trick again, if you want to apply a certain type of filter instead of what I did there, say if you want to filter just confirm request, you click on the field that makes a confirm request. Right click on that, you can apply as a filter. Now you're only looking at these type of requests. All right. Let's say we want to look at communication to and from a specific device. Monica, can we pause it? Okay, so we just looked at confirm requests and acknowledgements, actually any type of confirmed services. And again, you can mix and match these different filters if you want to look at communication to and from a particular device, knowing the IP address or Ethernet address, you can add that to the filter line by doing an and then, for example, IP dot address and so on and so on. So let's move on. One of the common things in BACnet, you want to look at communication, say, to and from a particular device with a device ID. In BACnet, we'll work so much with these device IDs. If you want to look for something with a certain device ID, here's how you do it. So a device ID is, first of all, a device, which means an object type that is a device, and then followed by the device ID. So we're going to use expression builder in this case, just because it's a little bit easier. So where am I? Back app again. And we're going to look for back app object type, so right here, and we're looking for device, which is actually number 8. Again, if you look at the standard, a object type 8 is mapped to a device. So we're going to use that, and then we're going to hit OK. It adds that. So now, if you were to apply this, you find any frame that refers to a device. You can match it here. You see down here, object identifier, object type, device. Now we're going to add the device ID. So I'm going to and back app, instance number. And again, you can do this in the expression builder. Just for sake here, we're going to use device instance number 1. Here are all the communication to and from, or that refers to device ID 1. And you can filter that even further. Say if you want to look at just confirmed services. So again, build on top of it. Oh, I apologize. Back app, confirmed services. Hit enter. And we see in this particular capture, there's only 2 frames, one there and one back, from 109 to 201, referring to device ID number 1. Show you one little trick in Wireshark to continue. If you say are doing a lot of comments, a lot of investigation, sometimes it's a good idea to add some comments. So, you know, hello, please take a look at this one. And this can be saved into the PCAP file. So let's remove this expression here. Let's add another one just for the heck of it. I don't know what this is. And now the interesting thing is that the frame itself the color doesn't change. So an easy way to look at the comments that you added throughout the file is to go to Analyze, Export Information. And this will show you the packets or your comments. And so, for example, 13.280, if you want to jump to it, another trick, go to Packet, or Control G, 13280, I think it was. And here it is, it jumped to it, and this packet with a comment. And this is what we typed in. Okay, if you want to keep your comments, you just save it onto the PCAP file or a new file, and you can keep that with you. Or again, remember, if you create a certain filter, you can save just the filtered frames. Sometimes you want to pass that to a vendor or to a peer, and this can be very, very useful to just narrow down why you think there's a problem. Other than that, let me cover a couple of questions that were asked during the webinar. So one of the questions that was asked is, what is the common cause for over-broadcast by a BACnet device? Steve provided some really good insight. One could be misprogramming. For example, if a COV threshold is set too low, it may cause a device to send way too many unconfirmed or confirmed unconfirmed COV. Or device that's just badly designed, but very often it's a programming issue. Second question was, what's a primary reason for malformed packets? In Ethernet, these should be less common, but typically a malformed packet indicates a physical problem with the connection of the devices. Very common in NSTP, so if the RS-485 wiring is not done properly, it can have some noise on the wire and cause malformed packets, packets with what we call FCS errors, a checksum error, which therefore means a packet needs to be thrown away. It's no good. And last question I'll cover right here in this little video is a great question, is what is the legal ramification of capturing packets on a customer system? Do we need to be concerned because Wireshark can capture everything, not just BACnet? It's a great question, and there's no hard answer, but yes, you should be concerned with it. You have to be careful. If you're going to capture Wireshark and take that information out, we recommend you check with your customer, your user, your peers, whether or not you're okay to do that. Typically, an easy way to get around any concerns is to capture only BACnet packets. BACnet packets typically will not include sensitive information, such as credit card information or authentication data. But even BACnet information, you do have to be careful. So, for example, if an IP address for BBMD gets out, it can cause some serious problems if someone wants to cause harm. So, run Wireshark with care. But it is a very, very powerful tool to help you diagnose, understand what is happening in the communication layer of your BACnet system, and sometimes help you point to issues, misprogramming, vendor incompatible communications, things like that. Very, very powerful tool, free tool. And again, thank you very much to Steve and his team there to create this amazing stack to allow Wireshark to read BACnet frames and help us dissect it. And last but not least, just a quick note, we are running 2 more webinars over the next couple of weeks. One, a very interesting one on cybersecurity of smart buildings called I Can Hack Your Building, Stop Me, where we'll be joined by Fred Gordy, a cybersecurity expert with Intelligent Buildings. It is run on September 15th. To sign up for this incredible webinar, please go to optigo.net under webinars. The next webinar covering BACnet diagnostics and troubleshooting. Check out Troubleshooting BACnet in Visual BACnet, a product that Optigo provides, and we'll have a great session to show how Visual BACnet, our tool, can help with some of this diagnostics, some of these troubleshooting and investigation tips that we just covered today, hopefully a lot quicker, a lot easier to use, and provide you an insight without having to remember all these filters. If you're interested, please check out visualbacnet.com. We're offering a 2-week free trial of the tool, so check it out, try it out, run Wireshark, capture the file, load it into Visual BACnet, and see what type of information it gives you. Again, thank you very much, Steve Karg, for joining us for this incredible insight. I hope this is helpful, and enjoy your day. Thank you. Bye-bye.